This next lesson talks about what happens when we get some different special solutions when we're solving equations. There's three things that can happen. So far, we've only seen the situation where we get one solution. In other words, our variable is equal to one number. So we have one number that is a solution. And what that means is it makes the equation true. I'm going to give you an example here. If you were to solve 3x minus 10 equals negative 2x plus 10, you're going to move this negative 2x because he's smaller. Over here, you would get 5x minus 10 equals 10. Trap your armadillo, plus 10. 5x equals 20. Divide by 5, x equals 4. 4 is the number that would actually make this equation true. If I did 3 times 4, that gives me 12, minus 10 is 2. Negative 2 times 4 is going to be negative 8 plus 10, which would also give me 2. 2 is going to be equal to 2 when I check this. Another situation that we haven't encountered before is a no solution situation. And what this means is when the equation is solved, we get non-equal values. Again, another example for you so that you can see what this actually looks like. If I gave you the equation 4x minus 5 equals 4x plus 8. Hopefully you've noticed that on both sides the x's are actually the same. That's kind of a signal to you that we might potentially have a no solution situation, or we might have an infinite solutions. I'm going to go ahead and move this 4x minus 4x. Over here, you'll notice 4x minus 4x cancel out. I'm left with a negative 5. A 4x and a minus 4x also cancel out. Here I'm left with an 8. Negative 5 equals 8, that's not a true statement. You need to put a slash through your equal sign. Since that's not a true statement, the final answer here is for us to actually say there's no solution. No matter what number we plug in for x, whether it's a fraction, an integer, a whole number, 0, we're never going to get any number that's actually going to make this equation true. It's not possible to happen. The last situation happens with what's called infinite solutions or an identity situation. And when this happens, both sides are the same. So, best way to see it is with an example. 4 plus 3x plus 1 equals 5x plus 5 minus 2x. So over here I notice I do have to combine some like terms, the 4 and the plus 1. I have 3x plus 5. And over here I have the 5x and the minus 2x, which is going to get me 3x plus 5. Notice that both sides of your equation are exactly the same. If I didn't realize that, and let's say I wanted to go ahead and minus the 3x from both sides, those cancel out, leaving me with 5. Those cancel out, leaving me with 5. 5 is equal to 5. This checks out. That's what happens, and that's what it's called when we have infinite solutions. And you can shorten that to SOL if you'd like, or you can write identity, ID. So looking down at the bottom of your notes page, there's a couple examples here. Drop your line down your equal sign. I'm going to move the 3x since he's smaller. So I'm going to be left with 4 equals 2x minus 10. Armadillo. 14 equals 2x. 7 equals x then. This is a one solution situation. There's one number that's going to actually work for x. Look at example number 2. Over here, nothing to work with. On the right side, I notice I need to combine some like terms. Negative 3m plus 12m is going to give me 9m plus 5. My m's are both the same, so I'll just work over here. Minus 9m. That leaves me with a negative 4. That leaves me with a 5. Does negative 4 equal 5? No, it doesn't. That's not a true statement. So for this equation, we have no solution. Over here, notice I have parentheses. I'm going to have to distribute 10x plus 12, multiplying 10x plus 12. Ooh, both the sides are exactly the same here. Since they're the same, I can stop at this point and just say that I have infinite solutions, or I could call it an identity situation. If you turn it over to the next page in your notes, a couple more examples here. This one is going to result in one solution, and x is going to be equal to -4. You want to go ahead and solve that one on your own. So pause the video, solve it, make sure you're combining your like terms, make sure you're distributing that 2 there. All right, hope you did okay there. Example number 2, let's take a look at this one. I have a distribute, so I'm going to take care of that. 6x minus 18 plus 10. On my right side, I also have a distribute, 6x minus 8 then. So taking a look at this one, over here I still have to combine some like terms. A -18 and a +10 will give me a -8. Oh, both sides are exactly the same. Since that happens, that means I have infinite solutions here. Let's try number 3 together. If I drop a line down my equal sign here, I need to distribute. 8 times 4 is 32, minus 16x. Distribute 12 minus 20x plus 4x. So over here I need to combine some like terms. I have -20x and 4x. That's going to give me -16x plus 12, 32 minus 16x. As your math teacher, I'm noticing this is a -16x and a -16x. So if they went away, I would have 32 equals 12. I know that that's not true, so I know this is a no solution scenario. Since you might not have picked up on that, you might have said, okay, let me add 16x. Don't forget the x there. 32, those cancel out. Those cancel out, 12. At this point, you better say 32 equals 12. No way. So there's no solution here. This next one right here, you're going to pause the video and you're going to do this one. You should end up with no solution as well. So in other words, you're going to get 2 numbers that are not equal to each other. Now that you've done that one, take a look at example number 5. It takes a graphic designer 1.5 hours to make 1 page on a website. Using a new software, the designer could complete a page in 1.25 hours, but it will take 8 hours to learn. How many pages would the designer have to make to save time using the software? So to save time, we're trying to find out when are they equal, because then we could figure out when would the software actually balance out. So let's say no software. It's 1.5 hours per page, so 1.5 times p, p being the number of pages we're going to make. With the software, we have 1.25 hours per page, but we also have to add on that extra 8 hours of the learning time. So let's figure out when they're equal. So we have 1.5p equals 1.25p plus 8. He's smaller over here, so I'm going to do minus 1.25p. Give me 0.25 pages equals 8. Divide by 0.25. P is going to equal 32 pages to save